disconnect is indeed required ahead of a generator transfer switch. According to the National Electrical Code, a disconnect switch is required between the generator and the electrical system. The purpose of this disconnect is to disconnect all ungrounded conductors. This requirement is primarily in place to protect personnel who may be working on the generator or its associated wiring. The disconnect prevents accidental electrical shock by isolating the generator from the electrical system. While some generator transfer switches come equipped with an integral disconnect, meaning the disconnect is built into the transfer switch unit itself, this is not a universal requirement. It's perfectly acceptable to have a separate disconnect switch installed upstream, meaning before the transfer switch. If locating a 400 amp transfer switch with an integral disconnect proves difficult or impossible, installing a separate disconnect switch is the appropriate solution. Given the limited space, there are several strategies to consider. Firstly, use a compact disconnect switch. These switches are designed to provide the necessary disconnection function in a smaller footprint, making them ideal for tight spaces. Secondly, mounting options can be explored. Mounting the disconnect switch on the CT cabinet itself or on the wall adjacent to the equipment can save valuable space. Thirdly, consider a transfer switch with a built-in load center. These integrated units combine the transfer switch functionality with a load center that includes a disconnect switch and circuit breakers, offering a consolidated solution. Ensuring code compliance is paramount. The disconnect switch and generator transfer switch must be installed in accordance with the National Electrical Code and any applicable local codes. This includes adhering to requirements for proper grounding, overcurrent protection, and clear labeling of the equipment. Branding ensures a safe path for fault occurrence, minimizing the risk of electrical shock. Overcurrent protection, typically provided by circuit breakers or fuses, protects the wiring and equipment from damage due to excessive current flow. Proper labeling helps identify the function of each component and ensures safe operation and maintenance. Given the substantial 400 amp service, seeking guidance from a qualified electrician is highly recommended. A professional electrician can assess the specific site conditions, determine the most appropriate disconnect switch and transfer switch configuration, and ensure that the installation meets all applicable safety and code requirements. They can also address any potential challenges related to space constraints or other site-specific factors. The disconnect is not just a suggestion, it is a safety requirement mandated by electrical codes. It is installed to isolate the generator from the electrical system during maintenance or emergencies, safeguarding personnel from electrical hazards. The disconnect interrupts the flow of electricity, preventing shocks and potential harm to those working on the system. The transfer switch, on the other hand, serves a different purpose. It switches the electrical load between the utility power and the generator power. When utility power is available, the transfer switch connects the load to the utility. When utility power fails, the transfer switch disconnects the load from the utility and connects it to the generator. This ensures a seamless transition to generator power, minimizing disruptions to essential services. There are two main types of transfer switches: automatic and manual. An automatic transfer switch, or AT, automatically detects a power outage and switches to generator power without any manual intervention. A manual transfer switch requires someone to manually switch the load from utility power to generator power. Automatic transfer switches are typically used in applications where uninterrupted power is critical, such as hospitals, data centers, and emergency services. Manual transfer switches are often used in residential or small commercial applications. The selection of a transfer switch depends on the specific needs of the application and the level of automation desired. When selecting a disconnect switch, several factors should be considered. Firstly, the amperage rating of the switch must be sufficient to handle the full load current of the generator. Secondly, the voltage rating of the switch must be compatible with the system voltage. Thirdly, the switch must be rated for the environment in which it will be installed. If the switch will be exposed to weather, it must be rated for outdoor use. Fourthly, the switch must meet all applicable safety standards and codes. In the context of a 120/208 volt three-phase system, the disconnect switch and transfer switch must be rated for this specific voltage and phase configuration. The 120/208 volt designation refers to the voltage between a phase and neutral, which is 120 volts, and the voltage between two phases, which is 208 volts. The three-phase designation indicates that the system uses three separate electrical phases, which are typically 120 degrees apart. This configuration is commonly used in commercial and industrial applications due to its efficiency and ability to handle large loads. When installing a generator and transfer switch, it is important to follow all applicable codes and regulations. The National Electrical Code provides detailed requirements for generator installations, including requirements for disconnect switches, transfer switches, grounding, and overcurrent protection. Local codes may also have additional requirements. It is essential to consult with a qualified electrician to ensure that the installation meets all applicable codes and regulations. Proper grounding is crucial for the safe operation of a generator and transfer switch. Grounding provides a path for fault currents, minimizing the risk of electrical shock. The grounding system must be installed in accordance with the National Electrical Code and any applicable local codes. Overcurrent protection, typically provided by circuit breakers or fuses, protects the wiring and equipment from damage due to excessive current flow. The overcurrent protection devices must be sized appropriately for the load and must be installed in accordance with the National Electrical Code. Labeling is also an important aspect of a generator installation. All components, including the disconnect switch, transfer switch, and circuit breakers, must be clearly labeled to identify their function. This helps ensure safe operation and maintenance. In addition to the technical aspects of the installation, it is also important to consider the safety aspects. Generators produce carbon monoxide, a deadly gas. The generator must be located in a well-ventilated area, away from windows, doors, and vents. Carbon monoxide detectors should be installed in the building to provide an early warning of carbon monoxide buildup. Generators also produce noise. The generator should be located in an area where the noise will not be a nuisance to neighbors. Noise barriers can be used to reduce the noise level. Regular maintenance is essential for the reliable operation of a generator. The generator should be inspected regularly for any signs of wear or damage. The oil should be changed regularly, and the air filter should be cleaned or replaced as needed. The generator should also be tested periodically to ensure that it is operating properly. When selecting a generator, it is important to consider the power requirements of the loads that will be powered by the generator. The generator must be sized appropriately to handle the full load current. It is also important to consider the starting surge of any motors that will be powered by the generator. Motors can draw a large amount of current when they start, which can overload the generator. A generator sizing calculator can be used to determine the appropriate size generator for a specific application. In summary, installing a generator and transfer switch requires careful planning and execution. It is essential to follow all applicable codes and regulations, and to consult with a qualified electrician to ensure a safe and reliable installation. The disconnect switch is a critical safety component that must be installed in accordance with the National Electrical Code. When determining the size of the disconnect, consult NEC section 430.110 if the generator is powering any motors or equipment with large motor loads. Article 445.12 is also a consideration, which covers sizing of the overcurrent protection. Also consider Article 700.16, which discusses the capacity of the system, if this is for emergency systems. Remember that the goal is to protect people and property, and that these requirements may change based on local codes, editions, and the authority having jurisdiction's interpretations.